Hi, I'm Ken. Ken Wheeler, that's Ken_Wheeler on Twitter, if you want to read a bunch of bullshit. All right. Before I get started, I just want to let you know I released this album of roller rink birthday party songs. It's on it's like 80s roller rink songs. It's pretty good. It's on Spotify and Apple Music and your mom's iWatch or whatever. So you should check it out. It's pretty good. And I'm here to talk about ReasonML. All right. Can I get a show of hands who's actually heard of ReasonML? Can I get a show of hands who's used it? That's why I'm here. So I don't usually do talks twice. I've traditionally done a different talk every single time I talk somewhere, right? But this one's special, right? So over at React Rally, I think it was. I was at React Rally and I'm walking through the hallway, and this incredibly handsome man in a suit came up and knocked me unconscious and gave this talk. And I don't know, you think I would know who he was because he sort of looks like me and knew a lot about Reason. It's kind of a small community, but totally stole my talk. So I'm here to actually give it today and not have this nerd steal my thunder. So we're here to talk about Reason. If you don't know what Reason is, it's a new syntax and tool chain for OCaml, right? So it's not a language, so to say. I mean, I guess it's sort of a language, but it's more of a syntactic extension. And despite being OCaml, right, it kind of looks and feels like new school cool kid JavaScript. And one of the really nice things is that it's all NPM and Yarn based workflows. By that I mean, typically if you're going to work in a language that's not JavaScript, you're not privy to our tool chain, the way that we run scripts or install dependencies, but this does, which is dope. So OCaml, if you're not familiar with that, that's kind of a funny one to sell, the whole OCaml thing. Let's talk about what OCaml is. Right, so it's a general purpose systems programming language. It's not not like a script language. This is regular programming. You can do systems programming code with it. It just so happens to be able to be compiled to JavaScript and run in the browser. But it does all the things. It's a meta language, which is part of a family of functional languages. You have things like standard ML, OCaml. The meta language family inspired a lot of the stuff you've probably seen, like Elm, that sort of thing. So that's always dope. And it's been around for quite some time. OCaml is, or at least has historically been, a pretty academic endeavor, and it's matured over 20 years. So a lot of the things that you would run into have been solved. And the thing that I guess one of the selling points of it is the types, and the types are really dope. And it uses things. So I guess it's called the Hindley-Milner type system. I was somewhere speaking about Reason, not this talk, but I was giving another talk, and I was like, the types are dope. And some guy's like, it's actually the Hindley-Milner type system. And I was like, oh, really? So I went and looked at the Wikipedia page and felt stupid. And but yeah, it's a specific type system that lends itself to have really good type inference. If you can I see show of hands who use TypeScript? Yeah. So yeah, a lot of the time there you're pretty explicit with the types, and this does a pretty good job of guessing it and inferring it. All right. So why should we use it? Right? Why in the world should we write our client-side web apps in a 20-year-old systems language? Right? So right off the bat, right, it's ridiculously fast, and I'll show a demo later that shows how absurdly fast. But just to put something out there, I think that when you're running it not compiled to JavaScript but natively, I think it goes neck and neck, if not has beaten C on certain things. So regular Reason is crazy fast. So why else, right? It's functional, right? It's a functional language, but it has side effects, mutation, and other escape hatches, right? Which means you can actually write a functional language in prod, which is nice. There's some Haskell guy like, I'm gonna kill you. Relax, shut up. No, it's yeah. yeah, you can actually put things in prod. I have put things in prod with this. I have an app in the App Store and the Play Store that's written in it. So I mean, you can take it to prod. So the next thing is the ergonomics of the language, which are really great. I have to elaborate. I'm not there. I'm like, yeah, the ergonomics, they're really great. They're the best ergonomics. I know ergonomics. No, they're fantastic. It gives you some like language level primitives that kind of changes the way you code, right? So I'll elaborate on that later. But I remember when I first started writing Reason, I was writing Reason, but I was writing it like JavaScriptily. And then, you know, some people were like way doper with Reason. Were like, yo, check this out, man. You can write it like this. And I was like, what? And, you know, if you know the primitives and when to use them, and you write it in like the Reason way, you know, a lot of the time it lends itself to, you know, better, more readable code, and you get to do all the fun functional stuff. Let you look down on your friends. So again, it has a really fantastic type system. So that's not just the inference, but also you know, the syntax by which you'll declare these types, and you know, just wrangle all the types. It's fantastic, right? So the last thing is what's crazy is that you could target JavaScript and native, right? So not only can you write the stuff, you know, you can use this language. So right now with JavaScript, right? We all write JavaScript, but like you know, you can't. I mean, I guess you could write Java. I mean, it's interpreted either way, but you can compile this down to you know, native code or bytecode, and you can also compile it to JavaScript, right? Right. So the bytecode, right, is kind of like an in between there. So you can compile it straight down to native, right? That's crazy fast, but it takes a little while to compile. There's a middle of the road there, and it has a bytecode and a bytecode runner, right? So you compile it, you lose a little bit on perf, but I mean, it's not like JavaScript speed, but it's you know, not quite like C. But you know, it's a bytecode, so it's a good middle of the road if you want to do things like hot reloading, which I'll show later, which is crazy, right? So the way we get it into JavaScript, right? We have the native, we have the bytecode, and then we have JavaScript, is with a project called BuckleScript. And BuckleScript is, you know, it transpiles OCaml and Reason to JavaScript, right? So one of the best things about it is that it when you actually have the rendered code, like if you look at the output of a lot of these build tools that we use, you know, a lot of us use, you know, TypeScript, or we use Babel, or you know, you have like Webpack bundling things up. You look at the output, and you know, you need like maps to see what exactly is going on. And then you look at the code, you're like, what's going on in here? It's crazy. What BuckleScript puts out is bananas. It is like really, really, really readable code, and has like these little like hint comments and stuff. It's really good stuff. And then the interop. If you ever worked with a language, right, where you're taking that language and you're compiling it to JavaScript, sometimes you can't just keep it on language. Sometimes, you know, as far as your like types being sound, right, you need to write bindings to JavaScript things, right? So if you're going to use a JavaScript library, or if you're going to use browser APIs, right, you have to write interop code and essentially write the binding. You have to say, like, if I'm going to do a set interval, for example, right? That first argument is going to be a function. The second one is either going to be an int or a float. And you know, you have to say that so that it can check against that and make sure that you're using it in the right way. A lot of the compiled to JS language interop stories that I've worked with have been a huge pain in the ass. Whereas here, it's kind of nice. I mean, yeah, doing interop bindings is a pain in the ass anyway. You want to slice the pie, but here it's my favorite so far. Right? So let's just take a look for a second. Let's see. How do I? Okay. Just take a look at like what BuckleScript renders to, right? So I have like a Reason file right here. Is this big enough? Type. Bigger. Enhance. Enhance. Is that too enhanced? Too advanced? Do you guys remember that website? Please tell me someone is as old as me. Right? So this is what the compiled BuckleScript looks like. Right? It'll give you this little comment up here. This is a demo that I'm going to do later, so I'm going to show actually more of this later, but I just want to show you the BuckleScript. This is what it compiles to. When you compile Reason to JavaScript, this is what you get. Please edit with care. It's so nice of them. You know this editor theme is dank, right? But yeah, this is what it renders to, which is pretty ridiculously readable, as far as I'm concerned. We can go, yeah, no side effect. Nice. Yeah, so we can run through that later, what's actually taking place here, but I just wanted to show you how incredibly readable that is. Something that you don't get very often, right? Yeah, so let's talk about belt, right? So when you're taking Reason, OCaml, let me back up for a second just to be clear here, right? So Reason is a syntactic extension of OCaml. OCaml allows you to extend the syntax. So it's not like an actual different language. It's like OCaml has like Babel built in, and you can write like Babel transforms for the language, right? So it's a syntax extension, and then it adds the stuff where you can manage your dependencies and run shit with NPM scripts. But again, that's literally OCaml, right? It's OCaml through and through. So when you're compiling to JavaScript, a lot of the optimization there and the way that things are set up is OCaml focused, right? So when you go to JavaScript, sometimes it's not as optimized for the way that JavaScript does things, and that's where Belt comes in. Belt is like a standard library, and when you're doing things with Belt, if you use some of their primitives, that is optimized for JavaScript. So if you know you have a JavaScript target in mind, you can use Belt, and on top of just being a good standard library, you get optimizations for JavaScript itself. Right? Also, the errors are completely bananas. Right? If you've ever used Elm, I know like when I used Elm, like the biggest part for me was like when you like hit save and like you got like this like sick colored readout with all this. It's like, hey, this thing like was like an int, but you supplied a float, and like if you wanted to, you can go ahead and run this and it'll convert it for you. I'm not saying you have to do it, but whatever. And I was like, wow, this is incredible. Like this is really wow. I'm used to like this like crazy like on the phone. So this has, OCaml has a very similar type setup. Let me see if I can throw it. Yeah, it shouldn't be really hard for me to throw an error, am I right? Yeah. Let's see if I can throw an error. Yeah, I'll just like supply something that shouldn't be there. But yeah, see this down here? Yeah, so it shows you, like highlights it. Right there, shows you the line and stuff. This has type int, but somewhere wanted unit. Unit is like null, but there is no null. I'll get to that. But yeah, it's good. It's good. The errors are pretty lovely. Right? So what does it look like? I mean, I kind of showed you what it looks like, but we're gonna really get into it. It looks like JavaScript for the most part. Literally. Looks like ES6, that's what you've been writing. Certain things, not so much, but we'll get to that. All right, so you see this right here? We got a little sum function here. This is valid Reason, right? It's also valid ES6 JavaScript, right? Same thing, indistinguishable. So let's get into some weird shit where it doesn't quite match up, right? So you see this right here. This is funny. We have a little tilde action here. What's going on here, right? So this is a named argument, right? So you can have named arguments in Reason, and that's what this tilde does. So down here, you don't. Oh, you fucking kidding me? Oh my god! Could have been worse. It could have like backed up really far, and then we would have been in real trouble. See, when I was browsing this morning. Hey now. Yeah, so so you can supply arguments with the named argument down here, right? You have sing hook, you specify the name there. If we had more than one argument, it would probably make more sense because now you don't have positional arguments. Now you can supply them in whatever order as long as they're labeled. Another thing you might see is this plus plus. Right? What in the world's going on there? So this is a string, All right, all strings in Reason and OCaml are double quotes for all your strings. I know. They're all double quotes, right? But this is actually string concatenation, right? Because this knows that name is a string, just based upon how it's being used, right? And you're supplying it here. It knows, right? You don't have to say, nowhere here am I saying string, right? But yeah, if I just tried to do like plus, right, it would be like, this is not an int. What are you doing? So different types when you're doing your operators, they have type-specific operators. So like if you wanted to add two floats together, it's plus period, right? So you have operator-specific or type-specific operators. So this is for strings. You do plus plus. That's what that's all about. Right? All right, let's talk about some other stuff, right? Records. We're probably used to objects in JavaScript. Now this has objects, right? But they're a little bit different. What you think of where you'd use an object in JavaScript, now you'd probably try and use a record when possible. They're immutable and they're super duper fast. So you would use a mutable object like if you really needed to, but I would default to records, generally speaking. So here's a funny thing, right? It looks just like a regular JavaScript object down here, right? I say let yay. Also, let is how you do. There's no const, right? It's just or no var either. Everything's let. So I say let yay equal this object age 41 name Kanye West. I don't know. Is he still 41? I think so. But if you just wrote this part down here, you get an error. And the reason is that somewhere in your project, you have to define a type that has a shape that matches this, right? So up here we have type person equals, right? And we have age, int, name, string. And this will go through just fine, right? Because this shape matches this, right? And at no point in time, TypeScript, I'm looking at you, do you have to, say like let yay colon person equal? None of that. No. The inference just knows, right? And beyond that, like if I try to add something to this, like a field on there, it would yell at me, and it would be like, hey, this is like type person, but you tried to add like this array of friends or something like that, and that doesn't exist on type person, so either do person or do another one. So yeah, the inference is pretty crazy. I'll show that later. Here's where you get into some real shenanigans, right? So as we saw before, like functions are pretty much the same. Everything's like this anonymous arrow function kind of setup. You have your arguments. We have let binding. Everything's cool there. Here's something that here's a concept that doesn't really exist in JavaScript. Now I'm gonna introduce variants, but variants and pattern matching kind of go together. So I'm gonna do variants, and then at first variants aren't gonna look to be super useful until you see where they get used with the pattern matching. So bear with me. So this is a variant, right? So I say type status equals, right? And then we have this pipe, right? And they have harder, better, faster, stronger, all right? And each one of these, so it's not just a type, it's a type and a data structure at the same time. This has a value of itself, right? So this is a thing that you can do expressions on, right? But it's also a type where it'll say like, hey, it was expecting one of harder, better, faster, stronger, but you supplied something that was not Kanye West lyrics, and it'll get mad at you, right? So it's important to realize that this is not just a type def, right? It's also a data structure, right? So let's look at one that's a little bit different, right? So they don't just kind of chill on their own. They can also take arguments, all right? So here we have this type album, right, of which we have two variants, not worth listening to, and Kanye albums. And I mean, if you're like me, you want to say which one you're currently into, right? You can put an argument on there, right? So you can be real specific. So my argument's a string. I could say let current album equal yay album with yay, right? So you're using it as a value, it's a thing, right? It's not just a type, right? It's literally a thing here. I'm using like a yay album, like a constructor, right, with an argument, right? So this is a very specific one. And that gets a little bit crazier, right? Now on its face, you're like, yeah, okay, that looks sort of cool, I guess. But here's where it gets dope, right? So this is pattern matching, right? Which is something that I really wish JavaScript had. It might soon. We'll see how it goes. So here I could say let amount equal 5, right? We're going to go ahead and set this to 5. And then we have a switch, like in JavaScript. But this is not the kind of switch that you're used to. In here, right, in the body, you have this pipe syntax, almost like the variance, right, where you have the conditions that you're going to match this on, right? So I mean, this is just right here, just amount 5, but you know, like a dynamic situation where amount could be a variety of things based upon when it's called, where it's called with. This is, so down here, the first one, I'm saying amount when amount is greater than 5, right? So we're saying if the amount is greater than 5, we're gonna return whoa buddy. If it's 5 itself, right, you could return exact. And then this underscore right here, right, we return almost there. What that underscore is that mean that's like the default one. So if I didn't have that underscore there, this would tell me that the pattern matching was not exhaustive enough, which is really helpful because it says like, hey, there's like a variety of things that amount can be, but you're not handling all of them. And that's one of the fundamental concepts here with Reason, where it is going to make, so I'll be upfront with you. I write shitty code, and I'm a big dummy. I like this, right? At first, it's like super like annoying because you're like writing code and it sucks, and there's things like you suck at programming. And then like eventually you're like, wow, like these are things that I don't handle with any kind of frequency, but this is kind of forcing my hand on doing it. So you know, now I can feel a lot better about my code. You know, like you know, when you have these languages that they're like, oh yeah, you're not going to get runtime errors, da da da. It's because, you know, I mean, you might get a runtime error. I don't know. You know, nothing's impossible. But like the chances of you getting a runtime error are vastly. I mean, it's like because it's making you handle everything, right? And that's what this is all about. Let's check this out. This is another one. I have this print list. Oh boy. Okay. So remember I said it made you handle everything? Here's a fun one. There's no null. Reason doesn't have null. Right? There's no such thing as null. So what it does have is has this thing. It's called an option monad, right? And what it is it's a built-in variant type where you can have none, or you can have some with an argument, right? And what that does is there's no concept of something being, you know, null or undefined. You either have some of something or you have none of something, and you have to handle it. So you have to handle cases where there could be nothing. So here we have this list of things, right? We're doing a pattern match on it, switch. If there's none, if there's a none type, you would actually explicitly return none, right? So if you did like a fetch somewhere and like nothing came back, you would return none as the value, right? Again, it's a variant, it's a type, it's a thing. You're returning a literal none, right? So you would go and switch on that. If you did have a list, right, you would return the list itself, right? And then you would use this pipeline operator to send the result of this to JS log, right, which is your console.log. How dope is the pipe operator? What? So down here you see print list, and you see a curious thing. I'm explicitly saying sum with the list. I'm not just passing the list in, right? That's because you have to, you know, you would have to explicitly say in a scenario where it could be null, you're going to say sum or none, right? I'm saying this is some list. If I just passed the list in, it would be like, hey, here we expected type option, but it was type list. That's funny. And I'm like, sorry, bud. Like, but you know, there you have it. Yeah, so that's one of the things that really helps with you know, not writing shitty code is, you know, not having the opportunity to have something come up null. Right? So now we're getting into some real weird stuff. So up to now, everything looked pretty useful and you know, wasn't too off the wall. This is a little bit of this takes a little getting used to, and that's the module system. Okay, so unlike JavaScript, there's no import or export. Right, so you never import from another thing. Right, bear with me. Modules, right? They're like mini files or namespaces, or in most cases, actual files. Right. Every single Reason file, every .re, is a module. Right. And they're all in the scope of your project at all times. So you're never importing everything. Everything is pretty much available to you. So like if we look here, right, we have this list of files in a Reason project. If I'm inside of item, right, I have info in my scope already, right? There's absolutely no import or export of any of these things. Now you can declare submodule namespaces within them, right? But you know, all this you know, import bracket business from wherever on your NPM or your local, that's not a thing here. It's all there, right? So let's take a look at what that looks like. Right, so let's say we're in test.re here, and I do let module property equal Yeezy 350 v2. It's a really lovely sneaker. If you, I like them. See these things? You can see these fucking things from space. Yeah. Sure. Here, girl. Okay. Sorry, I thought I got some shit on them. All right. So in another file, index.re, right here I say print inline and I say test.module property. Test, right, because we have test.re, capital T test is just available in index.re, right? And because I've done the let definition of module property inside of test, that is on there, right? That's part of that scope, right? So there's no import or any business like that. That's just there, right? It prints out Yeezy 350 v2. Again, fucking fantastic sneaker. So here's a different setup, right? I said before about the nested modules. So inside of test.re, right, I can use the module keyword to declare a module inside of a file, right? So I say module nested equals, right, and then this is kind of just like a scope of what's in that module, right? And here I can do this let handsome fellow equal Ken Wheeler. Am I right? Or am I right? And then index.re, right, I say test.nested, right, handsome fellow, weird ass string concat plus is handsome AF though. Here it says it prints Ken Wheeler, but it's really going to say Ken Wheeler is handsome AF though. But shitty at programming and making presentations. Yeah, index.re again, right? Here's a curious one, and that's the open keyword, right? So before we had you know, test is just kind of available, and we're like test.nested.handsome fellow, obviously Ken Wheeler. But in here, say you didn't want to do all that dot access on everything. This is something I really wish was in JavaScript. This is crazy, right? So open takes that module and kind of just spreads it right into the scope of your file, the entire global scope of your file that you're currently inside of, right? So you can just take, like, imagine if you took like Lodash and you could say like open Lodash and it was just like blah, like you don't have to underscore it, right? You just type, you know, flat or whatever, I don't know, smush map. Then in here, I just print inline nested handsome fellow, right? Because nested was a nested module within test, right? So nested is just kind of available here because we just blap right into the file. Good times. Now here's a funny one. You know, say you don't want to just blap that into the entire file. This is a funny syntax. So you can call the module, right? I can say like test.nested dot and then params here, and anything that is inside of these params now operates within the scope of this. So I can just say print inline handsome fellow, right? Because that is in the scope of nested. You could have multi-line stuff in here, and it's all there, right? So that's a funny one. Like if you have like a bunch of things that you want to do, that you know, you'd be writing like, you know, items dot whatever, what have you. You could do it right in there, right, with those brackets. So that's. Remember before I was talking about like the language ergonomics, like stuff like that, you're like, nice. It's pretty good. Yeah. So bindings. Bindings is that interop that I was talking about before, where if you're doing something in JavaScript, or you want to bring in a JavaScript library, you kind of have to keep your type system honest, right? It bridges JavaScript Reason. And what you're doing is, you know, you have a sound type system in Reason where you know, if your compiler's passing, there's a reasonable expectation that your app is not broken, which is good. But you need to keep that type system honest. If you write shitty bindings, you're introducing a vulnerability. You're completely, you know, removing any utility that typesound has had, right? So unfortunately, you have to write bindings, and they have to not suck. But it also gives you an opportunity to rethink certain APIs, right? So if you're bringing in something from JavaScript, something that's it has a specific like, JavaScript API or something like that. And now it's going to be in Reason. Here, you can say, hey, I kind of wish this worked like this. Or you could say, hey, Reason has these primitives. It has variants, or it has any of these language features here that would really lend itself to kind of like doing this in a more, I'm going to say it, reasonable way. But yeah, you see a lot of that where, like for example, in the React Native bindings for Reason, you have the style, right, which is the style sheet .create, right? We were able to sit there and define styles with JavaScript. Now, normally in regular JavaScript, right, styles are just a shit show. You can type whatever you want. You're like, ooh, whoop-de-doo, it didn't work. Like, it's not this. It was the wrong thing. It was like Flexbox. Like who remembers all that shit? But in the Reason bindings, it's actually super tight because a lot of the values that aren't like floats or integers, anything that's like a string, right, is often cast to like this enum, right, where you cannot screw it up, right? So it's like you have like these like typed styles where like, much like TypeScript, if you're using TypeScript, one of the things that I really like is when you start typing, right, you kind of get like code hints. It'll be like, you're like, my thing, and then you hit period, and it's like, hey, here's all the things, and then like you go to like one thing, and it's like, and this is the arguments it takes, and I'm like, buddy, but yeah, you get that in Reason too, and so let's just take a look real quick. Oh, I'm just gonna time check myself. Oh shit. All right. So yeah, this is a thing that I did for GraphQL. So after I did this, somebody else did it better, where you can actually type the GraphQL query itself. Like I said, I'm not that good at programming, so I just did it like this. But I'll show you how it goes. Right. So we have a GraphQL tag here. So I had this definitions, which was like kind of like the definitions of what we were expecting back there. And then you have this thing, BS module, right? So again, anytime you're doing any of this bridging, it's going to be in the context of BuckleScript, so you're going to see this BS prefix. And it's funny, because bullshit, but it's BuckleScript. So I have @BS .module, and then this is the name of the module, GraphQL tag. Like that's like, import default from GraphQL tag. So this is how you bring in a module, right? This would translate to like an import. And then you have this external, right, which is going to go ahead and expose the caller on that, right? And I say GQL here, right, which is just underscore GQL. And then I say it's a string, right? And it returns definitions, and that's going to equal default, right, which would be the default export, right? So I put in a string, which is a query, and then it sends back GraphQL tag returns like I think it's a GraphQL like AST of the actual query that you put through. But yeah, and then here I say let GQL query return GQL query here. So if we wanted to use it, right, it would be GraphQL tag dot GraphQL like this, and that makes the call to JavaScript. And the types match up, and your stuff's still sound. You might wonder what in the heckin' sniz is going on right here, but I'll go ahead and tell you. So this bracket with the pipe bracket, which looks so much doper with ligatures, but I digress. That's a multi-line string, so that would be like your backtick equivalent. So in here, if you've ever done GraphQL, you see you have like the tag template literal or just regular template literal where you do your query. That's this inside here. Now, somebody smarter than me did it way better, where it's not a multi-line string. You kind of just do it with the types like they did with the styles. But I didn't have time for all that, so there you have it. As good as I can do. Deal with it. So yeah, this is a React conference. Right? So I probably should talk about React. That'd be good. Right. So the relationship between Reason and React, I'll just preface this for a second. Jordan Walk was the creator of React at Facebook. And he created React, I think like the initial version, in standard ML, right? Which is like I guess like Camel cousin, right? And then eventually did it in JavaScript. But it was written in standard ML. And then we had React, right? And then we all saw React, and we're like, JSX is disgusting. And then we used it, and we're like, this is the best thing. And here we are, like, 4 years later. Look at us. I'm not as handsome as I once was, but we're having fun, right? So that same fellow, Jordan, went ahead and wrote Reason, right? He's one of the active developers of Reason right now, right? So if you like React, I'll tell you what, you're gonna love this Reason. So they've bridged React to Reason. And remember before I was talking about how you can rethink some things? So for the React bindings, they rethink. Is that a fucking word? Rethink. They rethink a lot of things. All right. So let's look at what Reason React looks like. This is routing. So this is React with Reason ergonomics, right? So first thing, let's just walk through this code so we can understand what is actually taking place. So I say let component equal, right? And then we have Reason React dot stateless component with the name app, right? So we're creating a new stateless component. The name of it, the identifier, is going to be app, right? And that's what's assigned to component, right? So then I say let make, right? So this is like exported at like a top level, right? In that same module system kind of thing. So you can imagine this is like a create element of sorts. So when you're creating a component, you say let make, and that's kind of how it works when you put it in JSX. Also, funny thing, just to touch on for a second, JSX is supported at a top level in Reason without React even being there. JSX is just supported. So if you wrap like a module or a function identifier in JSX brackets, it just gets executed as a function. Bananas. I digress. So here we spread the component in here, right? We have a named parameter message, right, which is our prop. We have a message prop, and then we have children, right? Then you have render, right? You have self here, right? So that's a little different. Have you ever wanted like just like props and state like right in your render function without going into this, right? Well, you have that here, right? It's called self, but we're not using self here. So anytime you have an argument that's there, right, and it's going to complain about it being there and you not using it, you prefix it with this underscore, and that just says, hey, I am fully aware of this argument this is getting called with. However, I'm not using it, so shut up, and it will. You got to learn how to make this thing shut up once in a while, because it'll be like, hey, what about this? And I'm like, I'm on top of it. Fucking relax. But then in here, it's like regular, JSX, except for one thing, and this is the hardest selling point for anybody that I'm making write Reason. The people who weren't going to write Reason in the first place, this is where like, I'm not writing this. Sorry, dude, I'm not even. So what it is in here, this is not HTML or JavaScript, so there's no idea of this like free-floating text stuff, right? So text actually has to be an element, and so do arrays, right? So in here, I have message, and I have to call reasonReact.string on message for that to actually get turned into text. So anytime you're going to use something in here, you're seeing these params, right, or parens, right? That's like the equivalent of like your brackets in JSX. And then if you're going to use something that's going to be a text value, you have to do reasonReact.string, right? And those people are going to be like, oh, I'm not going to do that. Well, guess what? You could do this and be like, hey, check this out. So I took message, and then I piped it to reasonReact.string, and I used the pipe in my JSX code, so now I'm cooler than you. So deal with it. That's one way around it, right? You can feel cool with your pipes, and then if you have ligatures, it looks like twice as dope. But now I'm really running out of time here. Okay, so let's take a look at stateful components for a second. Hold on, I'm gonna back out into demo mode. We're gonna just take a look at what this actually looks like. Okay, so this is actual Reason code right here, and this is the Reason React. Which one is it? This Reason app? Okay. Come here, you. Come here, you. Hey now. Shut the fuck up. God. All right. Just load her on up. No, don't worry. It's not impressive. Yeah, so I'm just going to run through some stuff that doesn't fit on a slide real quick. Let's look at a stateful component for a second. Is it? Yeah, okay. I'm just going to pull you down, you rascal. Okay, so before, right, I had the component where we did stateless component. If you have state, if you're going to use state, right, you do reducer component, right? And that's a stateful component. Now you see up here, I'm doing some type defs, right? You do type for your state up here, and you define the shape of that state. And then here, we have actions, right? And this action is a variant. Like I was saying before, we have increment and decrement. Or is it decrement? I don't fucking know. So here, you have a couple things that are different. You have an initial state, right? Where here you can return, here's count 0, right? This is like your initial one. And then, yeah, that's right, folks. There's a reducer built right the heck in. How about that? So here in the reducer, it takes action and state, and then you do the pattern matching, right, on this variant that I defined before on the action. So you pattern match on that, and then you call a thing. So there's 2 parts to the state update. If I'm down on my buttons here, right, and we have an event, right, we're going to go ahead and do a thing called, we have self, now we're using it. Self has a thing called send, right? This would be like your like dispatch, your Redux like dispatch with an action or something like that. And then here, calling send calls the component's reducer. And then what you're returning, this reason react update, this is what actually updates the state, right? So you're spreading the state. Count is state.count plus 1. Again, we have this disgusting reason react.string thing. You learn to love it. It's fine. One thing that's interesting is we're showing it. Again, we have reason react string. But because it's a string, we have to say string of int. Right? That's one thing to be aware of is the casting of the values. So, it's pretty uptight about that. But yeah, this is really all you need to do the counter example. Right? Below this is a list, right? And that's kind of tricky when you're first getting started, so I wanted to show you what doing a list looks like. So here, right, we have a list. We don't actually have a list. This is an array. It's going to ligature it, but I'll show you. Like a regular list just uses brackets, right? But when you put in pipes inside of there, that makes an array. I just use an array here because Reason and React uses an array, and I don't have to convert from list to array. Doesn't really matter. But in here, right, we have our parens instead of the brackets. I say items. This is a pipe. Remember I was saying it looks dope with the ligatures? I'm not kidding. It looks dope with the ligatures. Look at that shit. Yeah, so you pipe it to array.map, right, where here I kind of just return like LIs with the item. And then you pipe that to reason react array, which is like reason react string, but for arrays. So much fun. Okay. So I do not have time on my side here. Let's go through this quick. I'm going to go forget BS React Native. Let's go to reprocessing for a second. So outside of React, they have has anybody ever used processing? Right? They ported that to Reason. There's a thing called reprocessing, and it's pretty dope. And I wanted to use it to show an example of the hot reloading with the bytecode. I said it was fast before, but I want to just be real freaking clear on how fast that is. All right, so let's come here, hit npm start, right? And we have a square. Cool square, Ken. You can drag it around. So what this does is it renders OpenGL here to the screen. This is OpenGL. It's smooth and fast and everything that the web isn't. Who said that? I didn't say that. But let me drag this over here. Okay. So what I'm going to do is I'm going to go ahead and edit this, right? This is set up on hot reloading, okay? So we could edit the square size, right? I can put it to 300. I'm going to hit save, right? I want to show you when I hit save so you can see what I'm talking about, how quick this is. Watch my finger drop and then watch it on the screen. That's how fast hot reloading is. Yeah. Do you see how fast that is? Yeah. So you might be saying, oh, yeah, but that's pretty fast. You know, my dumb square building thing my client wants me to do. But trust me, you can build cool things with it. I promise you. I built a little old thing. I called it Top Speed 2069. So this is all just like immediate mode drawing to GL. It's tight. So yeah, it's pretty dank, and you can do some cool stuff with it other than drawing dork squares. I got about 4 minutes left. So I just want to talk about how to get started, and then if I have time, I have a dumb demo that's half-baked. So if you wanted to get started, one of the first things that you want to do is you come to the Reason docs here, and then they're going to be like, why am I on record? Okay. So you want to add BS platform globally. Once you've done that, you run BSB init, my new project. Here you have theme basic Reason. Right? This is like if you just want to compile Reason to JavaScript. There's other themes, like you could do a BSB init on Reason React, and it has a theme, but that's probably the easiest way to get started there. They also have like create React app for Reason, which is pretty dope, and they have other ones for React Native. If you want to go ahead and try it, right, here you can kind of see like what that actually compiles to, right, if you're that curious character that wants to see all that. Alternatively, if you want to try it here, right, Replit, which is a fantastic resource that'll let you write all kinds of shit, like including actually QBasic, which I thought was crazy. I was like, damn, Replit, you nasty. But here they have React Reason built in, so you can kind of toy with that here and have all kinds of fun. I think Code Sandbox supports it too, if I'm not mistaken. And then also they have, if you're like the Python notebook type, I'm not saying anything, but it's you have notebooks for Reason. So if you want to, be smart about something and send people stuff, you could do that. This is actually really fun to work with. Yeah, so those are some good ways to go ahead and get started. I wanted to show you like what something real looks like. I have 2 minutes left. I tried to build this demo, and it didn't get all the way there. What I wanted to do, have you guys seen this new video with Kanye and Lil Pump? It's kind of my jam right now, right? So I was like, oh, this is shit. So I wanted to use, last year I came here and I made a Jay-Z beat with React. So what I wanted to do was, make the baseline with Reason, right? And I'm pretty close here, right? So I just wanted to show what I had to do. I have like another minute left to get that done. So this is what like actual like writing something other than hello world looks like. This is all the BuckleScript bindings here, right? So this is the web audio API. These are the bindings essentially set up here. So I have like create context, audio context, create gain, create oscillator, set interval, set timeout, clear interval. Up here we type these out. I thought this was really funny. Like BS is funny enough in the first place, but then bs.meth. I was like, are you serious? But that's like if you have like a method on something that you're bringing in. But I still giggle at this shit. bs.meth. I'm like that's dank. But yeah, so we're saying like if you have like a gain node, right? Gain nodes, like it's the web audio is like a graph type thing. So like you can do like connect to all the different nodes, right? Connect is like a method on that. So BS, meth, connect, right? So you can connect these all together. And then some funny stuff, right? So with web audio, it's kind of funny. Like you create an oscillator, but you can only play it once. So every note, you have to create a new oscillator. So in here, I take like the audio context, note, length, and weight, create a new oscillator, come through and play it, right? Because it's bridged from JavaScript, right? That's why I'm doing this, it's technically JavaScript objects, not records, which is why I have to do like the double pound dot access instead of direct dot access. But that's what you're seeing there. Also, all of Reason does implicit returns, right? So if you have something that's at the bottom and you don't like set timeout, like I should probably be storing that and clearing it. But let's say you weren't, or you had something like that returns something at the bottom and you want to ignore it, you can just pipe it to ignore like that, and that's a good way to deal with that returning stuff. But yeah, in here, right, I set up some frequencies for some notes. I bridged over add event listener on the spot. I have a thing called run. This is actually a pretty fun thing because if we go into index.html here, right, I use a script type module, that new hotness, right, and I can import run from the compiled BuckleScript and then run there. And then this compiled thing will actually import audio from the audio one right there. So it's like the browser module system working. So I thought that was kind of cool out here using the platform. Look at me. And then in here, I have this create loop thing, right, where you kind of just specify notes and then like their position in like a 16-tick step sequencer and their note lengths. And then on start, you run loop.start, add event listener right there. I'll put this code up somewhere, but I don't even think you can even hear it. Let me see, is this? So, yeah. I don't have audio up here, so you can. It's like a sine wave on my computer, so you can't hear it. But I promise you, it plays the bass line. I'm up here. I'm like, I don't know. All right. Yeah, I'll put that up. That's Reason. Go try it. Thanks, everybody.